So here's a relatable thing we can all relate to. Have you ever put perchloric acid onto bismuth metal and then blowtorched it and noticed that it explodes? What's up with that? Hello, welcome back to another episode of Explosions and Fire. Today we're talking about the reaction between bismuth metal and perchloric acid, so let's introduce our two combatants. Perchloric acid is a really strong but rather scary acid. It's scary because perchlorates have a lot of oxygen in them, so in a pyrotechnic sense they're very good oxidizers. They can provide a lot of oxygen to a fire or a fuel. So perchlorates are often used in everyday applications like fireworks and rockets and sidewinder missiles. Perchloric acid itself isn't too oxidizing as long as it's 70% or below, and that's what I have here. Above 70% you get into anhydrous perchloric acid, which is a stupendously dangerous chemical. No one is keeping that around. That's not something that I have. Perchlorates are also surprisingly poisonous too, and that's because your body is a moron and it looks at a pile of perchlorates and thinks, that's the important nutrient iodine. But it is not the biologically active important nutrient iodine. But what about the metal? I offend a lot of people when I start talking about specific elements. Bismuth sort of sits at the bottom of the periodic table and doesn't really tend to bother people too much. It has seen a bit of a revival lately as a bit of a relatable icon element because it forms rainbows all the time, doesn't like to be straight, and is incredibly dense. Personally, I've always thought of bismuth as lead for people who fear death. But in this case, bismuth is doing something that no other element does: blow up on contact with hot perchloric acid. To see this a little better, we can quite easily melt some bismuth down over a camp stove and a blowtorch because I have very low amounts of patience. We can form these nice, smooth, flat surfaces for which to drop some perchloric acid on. On heating, we can see that a black layer forms which quickly detonates. The layer never burns off or slightly smokes off, it's always full detonation of this small black layer. This reaction was the subject of a paper in 1935 which tries to go through and determine what exactly is happening here, so we can follow some of their tests and see if we can determine what's going on. Firstly, perchlorate salts are pretty reactive and good oxidizers, so is this just bismuth perchlorate blowing up here? Well, we can rule that out using this weirdly yellow bismuth oxide here. If it was just bismuth perchlorate blowing up, we should see the same reaction between perchloric acid and bismuth oxide, and we don't see anything. In fact, we can heat bismuth oxide with perchloric acid and form bismuth perchlorate and see that it's not any more explosive than any other perchlorate, so it's definitely not responsible for those full detonations we see, or maybe the metal's doing something weird. You can kind of rule that out because no other acids react with bismuth in this way. It just reacts how you'd expect. There's never any explosions. So this reaction is only between perchloric acid and bismuth, so it has to do something with the perchloric acid. If you use slightly weaker perchloric acid, it has no reaction with that bismuth metal. It just slowly dissolves it and forms bismuth perchlorate as you'd expect. Maybe the bismuth surface is fracturing a little bit and we're getting some intimate mix of bismuth powder and the oxidizing perchloric acid. You can test that too with my fancy new bowl mill. We can make some bismuth powder. Shouldn't take very long because bismuth metal is so brittle I could probably just hit it with a hammer and it would be done. No! I spent money on this bowl mill, I'm gonna bloody use it. So in just over 2 weeks we get some very fine bismuth powder. We can see that has no explosive reaction with perchlorates. Sure, it's still acting as a metal powder with an oxidizer, but it's not having that full-on detonations that we're seeing from the bismuth metal surface. It really does appear that we're creating a new compound here on the surface, and we can test that further by actually trying to remove some of the black compound from the surface of the bismuth. We can see that it still has its explosive properties, so we're forming an independent explosive here on the bismuth surface that is just so sensitive that it's exploding as the bismuth is getting heated. An interesting observation about this compound is that it's destroyed on contact with water, forming bismuth oxychloride, which is this sort of milky suspension you see there. All this evidence seems to point towards making a really high oxidation state, unstable bismuth compound, except for the observation that the black layer has no oxidizing capabilities. It can't even turn iodide into iodine in solution. If it was a very high oxidation state bismuth compound like bismuth 5, you would expect that it would have a lot of these oxidizing capabilities. So the authors basically shrug and say, hey, we couldn't work out what it is, but they do speculate that it might be bismuth in a very rare oxidation state, +1 or +2, and that's what's making it so unstable, but they couldn't work out a test to determine if that was the case. Since 1935, there's been a grand total of 0 papers on this subject. And I know what you're thinking, surely science has developed somewhat since 1935. Don't we fucking have techniques where we just shoot lasers at things and x-rays and it just tells you what the oxidation state is with fucking a bit of math? Surely we've developed things since the 1930s. And the answer is yes. We could determine what it is. Like, if you've got access to, you know, x-ray stuff, just, I mean, do it. Like, put me in the acknowledgements somewhere. I don't know. Fucking whatever. Bismuth in fucking oxidation state 1 or 2. Like, that's cool. That's a fucking paper. Shit, man. Don't ask me for funding. Just fucking... Right. I can sense you need a little bit more motivation. Seeing as technically this is an explosive, if you discover what it is and characterize it, you get to name it. Very quick history lesson. One of the main explosives in World War I was TNT, trinitrotoluene, so its name describes what the structure is. However, in World War II, the British invented a new explosive that they didn't want other people to know about, so they couldn't give it an acronym that described its formula. So instead, they gave it a meaningless acronym. If you knew the name RDX, it didn't tell you any information about the actual explosive. Things got a bit out of hand when they invented another explosive that was very similar to the first one, so they gave it an acronym that was kind of similar. They called it HMX. It's a 3-letter acronym designed to sound like RDX, which is a 3-letter acronym which has no meaning whatsoever. And ever since, there's been a trend to give acronyms to explosives that are completely meaningless, but at least lets you call them something. For example, take this explosive here. This is diamino dinitroethane. Ethane. Take this explosive here, invented in the 1990s, diamino dinitroethane. You'd think then you'd give it an acronym like DADNE, dandy. But no, the authors decided to call it FOX7. Does FOX stand for anything? No. Was there 6 other Foxes before this one? No. They just made it, decided that FOX7 was a good acronym. Goddamn Swedish berries. You characterize this explosive, you can call it any 3-letter acronym you want, as long as it's not taken. Fucking call it Cox 1.
Nah. It's taken.
Cox 2.
No.
What about Ass 1?
Also no.
I don't know, Piss 1?
No.
Fucking Piss 2? Yeah, whatever, call it Piss 2. I have a new high-speed camera, so let's point it at some of these bismuth explosions and see what we can see. At 1500 frames per second, we really don't see much. It is a detonation of a small amount of material, so we will need to go to higher frame rates. Even at 6000 frames per second, we really don't see too much happening. In one frame it's there, and then the next frame it's not there. So we need to max out this camera going to nearly 33,000 frames per second. At this frame rate, we can finally see the explosion propagating across the surface, which I wasn't expecting to be able to see, but that's really cool, that we can see this explosion sort of traveling across the bismuth. So it doesn't happen everywhere at once, but one corner or somewhere in the center starts, and then that explosion propagates across that bismuth surface. So yeah, that's about all I've got, because I'm legally not allowed to have x-ray equipment, apparently. So that's on you to solve this thing. And feel free to support me on Patreon, and you can support more fucking hard-hitting and bloody relevant videos like this one that we can all relate to. Turn gloves into grape soda. Now that's content you can fucking relate to. Yeah. Gloves into grape soda, man. That's gloves into fucking grape soda, man. Fucking grapes.